Cool. So basically, today, what I want to talk to you about is the approach of adding security to DevOps. And in order to do so, I want to introduce you to a few slides that are going to talk about, how to do so and what are the best methodologies and tools and what exactly it means to be basically working with DevSecOps rather than DevOps. Okay. I'm also going to talk about a few tools. I'm going to show you some open source tools that we have as part of the CyberArk portfolio. But before I do anything of that, let's just introduce myself. So my name is Andrea Cappuccinello. I'm a security services consultant for DevOps. I work with CyberArk, obviously. I also do video games, so feel free to double check my portfolio later on. It's going to be part of the links, but that's completely sideways. I work directly with customers, so I'm basically a consultant that runs architectures, runs infrastructure designs, and helps building the full software development lifecycle from a customer perspective, or helping partners as well. And I do cover all of that. Just to give you a rare picture of myself 15 years ago, this is how I used to have fun on Halloween. So that's just a very rare picture of me from 15 years ago. Sorry for the quality. And this is how I'm having fun now. So just to give you a quick idea of what the security status is currently in the DevOps world and what is happening right now with all the companies that are now approaching DevSecOps for the first time, and what does exactly that means. So let's first of all, let's go ahead and start talking about what are the security risks. Okay, so we're going to just jump in and quickly straight away share some horror stories. So some of the bad things that can happen, and what could happen, for example, if you get hackers or any malevolent entity to gain access to your systems. This is a clear example. So as you can see here, we have a very huge fine that was paid like 2 years ago, almost at Halloween, basically, poor Uber. And this is just an example of what could happen if someone gets access to your data. Okay, so it's a very clear example. It's straight away from BBC, so just wanted to keep it UK based, but that's it. That's it. So you can see what could happen potentially and what are the risks. Let's have a look at the facts. Actual attacks can be very, very simple. Just a web browser is all you need to actually be able to find out what some secrets to companies are. Okay, so here, this example, let me just switch to the laser pointer. We just can see that just by searching AWS access key into GitHub, we're already finding some stuff. Obviously, some of them might be outdated now, but there's still potential and risks of credentials getting leaked just by pushing the wrong commit into your repositories, right? So that's a clear and simple example. What is the problem? The problem is more often we have embedded secrets. So as you can see here, potentially the developers already remediated and they tried to remove the hard-coded secrets, the hard-coded credentials from the commitment, but they forgot to remove them from the history. So they could potentially still be there. And the issue is that we can still see that they are actually hard-coded and they are part of the code itself. Okay, so we're just giving them in clear, and they could potentially give hackers access to sensitive data, or just to allow them to move laterally and and basically own your whole company. So that's very risky, right? It's quite a horrific story here. Just to see an example. When we actually think of the DevOps maturity curve, right, there are multiple dimensions to it. So I couldn't find something too small to fit in here, but you get the gist of it. So first, consider the maturity of DevOps technologies and approaches. So potentially many of you that are in the field may still be using manual, people-centric approaches. This still introduces some risks. If there is a lack of control over the levels of access granted to developers and tools, humane error could be an issue here. Think misconfiguration, right? So it could be still an issue. As organizations progress along the maturity curve, they typically start using a hybrid approach where there may be good control over people, but only partial control over the dynamicism of DevOps environments. In this stage, there may be scripts that are automating some processes, and some organizations may be using tools for automatic threat detection at this point in time. This approach still introduces greatest risks because of the mix of tools and processes being used. And often there is a lack of consistent security policies and oversight that can still be there. Many simply aren't aware of the risks introduced by the use of multiple automated tools, and many of which requires privileged credentials to do their job and are a frequent target for attackers. We can see something about that later, so I'm going to show you an example, a clear example of what could happen if a CI/CD tool actually gets too much access. The end game, so the desired future state, is high DevOps maturity in terms of adoption and culture, and also using fully automated tools. So this is where security best practices, for example, like least privilege, so just to give you one, and we'll see about that, about some more of them shortly, can be applied. So as long as security best practices are applied, the goal here is to ensure that there is as much smaller attack surface and that we have the highest security profile possible for our business. So this is just a quick example of a DevOps maturity framework. Okay, so if any of you knows about the DevOps Cup, it's a cup that just was started last year, and this is an example of the actual maturity framework that won that cup. Okay, and I just wanted to highlight here the actual shift left on security. So these are actually the steps of moving from a crawl to a walk and to a run, right? And the problem here that you can clearly see is that right now, both for crawl and walk, security aspects are considered, but they're not a priority, or they're not even not considered at all. So in the crawl stage, no security aspects are considered. So this is an example of what not to have in terms of a shift left approach to security, right? Because we really want to make sure that even during the crawl stage, we are protected, because there is the potential for getting a breach is there ever since from the very beginning. So from the start, there's going to be a risk for your infrastructure, especially if you don't consider security. So let's see, what are the objectives, right? So we know that the consequences of data breaches are both familiar and painful, okay? And again, there's just a little list of all the horror things that can happen, or all the spooky things that could happen if you get at risk here. What are the goals? We want to eliminate, or well, at least significantly reduce, and obviously at some point our end goal is going to be to eliminate fully susceptibility to cyber attacks. We want to prevent compromise of sensitive customer, employee, and business critical data. Okay, so we want to make sure that those are our goals. And in terms of application security, we want to protect sensitive data from leaks that could damage reputation and impact of the business. And we also want to minimize risks and security defects in software build cycles, or SDLC, effectively. So let's have a look here. Hard-coded credentials, right, and other challenges. So let's have a look at what are the current challenges that we approach whenever we get in touch with customers, and what we see, especially from a business perspective, for all the enterprises out there, right? So first of all, we notice that application credentials exists everywhere. So they exist in servers, databases, applications, cloud infrastructure, containers, network devices, scripts, etc. And because they exist everywhere, there are a large number of them throughout IT environments, development environments, cloud infrastructure, etc. So typically, we have seen that there are approximately 3 to 4 times the number of privileged accounts as employees within a company. Huge, right? So they are stored locally. Sorry. They're stored locally. So application credentials are often unmanaged, locally stored, for example, locally stored SSH keys, right? Which can be easily compromised, copied, moved, etc. So that was very critical. And another important thing, just evolving from here, is that security islands were caused by multiple secret stores. What does it mean? Security islands are what we consider an isolated subsystem that makes it harder to manage the security of your systems as a whole, right? Because basically what happens is, for example, if you use stores local to your CI/CD tool, you're going to start creating more security islands and that can cause chaos because you have multiple places where you need to look for credentials, or you can create duplicates, and some of them might not be secured. Secrets were mostly hard-coded in clear text. So what we've seen is that most times applications or even automations, right? Because at the end of the day, they are also part of the application portfolio within companies, were hard-coded and they were just simply in plain text. So you could just get to see them as long as you could have gotten access to the actual code, right? In addition, when credentials are hard-coded and or locally stored, the problem is that they are nearly impossible to rotate. Okay, so that just makes them an additional static and easy target for attackers. So they were basically static and they were getting age, which is very important in terms of securing your secrets. Additionally, as we've seen earlier on, we have seen cases where secrets were leaked to public repositories accidentally. So it can still happen that you just push your commit and it happens that the secrets are just there in plain text and all of a sudden they're out there. So even people that normally shouldn't have seen them can now gain access to them, right? And we're not talking about public repositories only. We are also talking about internal repositories and internal people that could still potentially be an actual attack cause, right? Additionally, they lack accountability. So whenever application credentials are coded, most of the time, or are embedded in scripts, most of the time it's difficult to track who or what has access to them and what they're doing with that access. With no central management of these credentials, there is no way to track or assign accountability to application credentials use, right? Finally, in a scenario, we basically got into an attack right in the middle of working with credentials that just made us change all priorities, and that just scrambled the whole plans and all the ideas that we were trying to do to secure the systems. So this can also happen, right? You can also get attacks right when you're right in the middle of securing the system. Let's have a quick look at security risks by numbers. Just very quickly, this is a very simple study that was provided by IBM, where we can see where do security compromises most likely occur. And look at that. Surprisingly, applications, they actually have the highest potential and risk for secrets to be leaked outside. Okay. And it's, again, we've seen the GitHub example, and there's plenty more. So there's plenty of horror stories. Now I can't really tell you about all of them, but there's really plenty of horror stories related to secrets that just got leaked accidentally outside, right, in hard-coded credentials. Let's have a look at how can we remediate. So let's have a look at something very simple. And meet the OWASP Foundation. So for those of you who don't know, shame on you, you should all know about the OWASP Foundation right now. If you haven't, just have a look at owasp.org. Okay, so just point there. The OWASP Foundation is a non-profit foundation, fully open source, that works to improve the security of software. There's plenty of projects. They're generally community-led. They're open source and they are freely available. So you just go to the website and you will be able to find some of them. And one example is the famous OWASP ZAP, okay, which is an open source web application security scanner. So obviously super useful whenever you want to start a discovery process. It is intended to be used by both, so the HOWASP Foundation and all the projects in general are intended to be used by both those that are new to application security as well as professional penetration testers, right? So they can cover the whole range. But we wanted to talk about applications here. It's going to take me too long to actually be able to stay here and talk to you about each one of them. But this is just the top 10 critical security areas that software developers must be aware of. And this applies to the DevOps world as well. So always be mindful that your automations and your CI/CD tools are also applications in their own way, right? So you need to be able to secure them. And there's a lot of models here and principles that are, and you can find everything on the OWASP website, so feel free to go and check that. So just by following this principle, this will greatly help your efforts to build more secure software and automations in the DevOps world. So this is pretty useful, and I really recommend you to go and have a look at it. Now, as I was telling you earlier on, I just wanted to give you an example of a case or a horror story where many credentials were actually controlled by one application. So we're talking about CI/CD tools here, and this is a clear example. So one of the first thing that you need to do in terms of discovery, right? Whenever you need to find out what needs to be secured at the earliest stage of your approach to security in DevOps, is basically identifying the critical tools in the workflows that have access to the keys of the kingdom. In this example here, Jenkins was an actual critical application because he was having access to multiple parts of the whole infrastructure. So it was able to move through environments, it was able to move through network infrastructure, and it was having controls over the individual singular provisioning of applications, right? Because at the end of the day, just by providing to Terraform and then into the containers, it still had access to the whole thing. So bear in mind that one of the first things to do is always identify what type of applications you have, what type of tools you're using, and make sure that you get the critical ones and you secure them straight away. I'm going to talk about how to secure them just in the next session. So how to approach the problem? This is something that in CyberArk we call working on blueprints. So feel free to check the CyberArk website if you want. We have a lot of free white papers that talk about blueprints and how to work in stages and approach solutions both to monolithic machines, monolithic applications, and all the way down to containers and microservices, or general security over your whole privileged accounts. But in here, we just want to build a security project model that will add security into DevOps, right? So at first, we want to have a rapid risk mitigation, so discovery and identify critical applications and CI/CD tools. We want to make sure that we lock down all other technology platforms on a second stage. So we want to expand and move on to the other critical part of the tools, for example, Terraform in the previous slide. We want to make sure that we incorporate privilege access management throughout the whole strategy. So we will just refine the pipelines and streamline all the processes so that we make sure that all the privileged accounts are secured. At some point, we want to mature the program, so we want to move forward with it. And finally, at stage 5, we want to shore up remaining vulnerabilities. So we want to just double check that we don't have any application that is really using any more hard-coded credentials. So what are the key objectives? We want to control access. We want to protect the data. We want to secure the credentials. We want to have a security hygiene process that will be an ongoing process to the whole DevOps pipelines and controls. And obviously, most importantly of all, we want to adopt a shift-left approach to security. So we want to make sure that we include security as early as possible in the process. Just very quickly, because we're running out of time, just a quick overview of the tools that we have available and that you can freely download because they are open source. So first of all, let's have a look at what hard-coded credential means and what is the different approach using a central vault, aka Conjure. So basically, this is the initial approach, right? We have hard-coded credentials that we use throughout our application examples to connect to our targets, and these targets can be any type of enterprise resource, really. Okay, there's a significant security vulnerability here. They're very hard to rotate and manage because imagine a developer that has a hard-coded credential never knows when and if by rotating that credential they will cause some blackouts in some other parts of the infrastructure. So you never know if by just rotating some credentials that are critical, some other applications might not be able to connect to the targets anymore, right? There's no way also to track or assign accountability to the actual credential used because you don't really know which application is actually accessing the target, right? We don't know the identity of the application. Basically, by using a central vault, what you're going to do, you're basically going to exchange the actual credentials with methods that are going to be part of the logic of the application workflow or the CI/CD tool that are going to basically collect the credentials from an actual central vault. So the credentials will not be available to the application anymore. There's no way that you can expose them, and they're just going to be secured. Okay, so this is a very basic approach. And it just allows you to be able to access targets more securely and to remove credentials hard-coded into your infrastructure. You can try Conjure open source at www.conjure.org. So feel free to go there. It's publicly available. It's also on GitHub. And again, you can just have a look at the website and you'll have all the relevant links. The resources that are available, we have a growing community. It's based on discourse. We have obviously GitHub as mentioned, and you can find the link just here. And additionally, you could potentially just sign up for all the CyberArk DevOps related seminars and workshops that we have directly within the CyberArk main website. So I will let you obviously go there if you want to, but there's plenty of materials, there's plenty of resources that are available. They talk generically about security, right? So they are not specifically focused on CyberArk only, but they just talk about security and the DevOps side of things, so all the access to applications and CI/CD tools. Just a quick introduction to the Secretless Broker, which is another open source tool. It's just an easier way for developers, and it improves security over platform as a services and applications in general, all the workloads. So at the beginning, we have like the no solution method, so where we have our coded credentials. And we can see here the example. Obviously, this is at risk. It widely exposes credentials. Still, with a vault, there's still a little potential for leaks, right? Because at the end of the day, the application will have the credentials, and you don't know what components, what modules, what plugins your application or your CI/CD tool has that could still potentially leak outside, right? Obviously, you will want to isolate that, but that's an additional process that causes some additional workflows to your application. With Secretless, though, which is an open source tool, you are basically fully isolating the application. So the application will not be able to leak what they don't have, right? So the application will never be able to access the secrets because the connection to the target will actually be brokered by the Secretless container. Just how does it work? Very quickly, I'm going to run this quickly because we're running out of time. Basically, Secretless acts as a broker based on the actual socket. It just gets the connection from your application, so it doesn't matter what credentials and what secrets the application has because they will not be relevant. It just needs to be able to log, instead of connecting to the target, it will need to connect to the actual container, so to the sidecar container that is running alongside the application itself or on a secured machine that has some other additional proxying capabilities. The proxy will just contact the service connector based on what type of socket is being used. This service connector will choose a credential provider based on your configuration, and you can have multiple ones. You can even create your own. Additionally, this credential provider will contact an external vault, so it will be able to basically collect the secrets from outside. And at this point in time, it will just inject the secrets into the connection string. Okay, so the application will, so the service connector will actually connect to the target and will then stream the connection directly back into your own application, right? So if it's a database, it will potentially just stream the queries that you are running, and the application will never know that it's not connected directly to your target, to your database. How to get started? See, it's super easy. Secretless can be downloaded, and it's available on Docker Hub as of now, so you can just collect it from Docker Hub. It's generally deployed as a sidecar container, as I was mentioning, to your application code. It can be deployed also inside platform as a services, so it's pretty useful if you're using Kubernetes or OpenShift. It shares trusted network stacks with other application codes, which grants your application basically transparent access to secrets via the secretless broker sidecar container. And you can review the source code, because it's open source, directly from GitHub. So feel free to double check github.com/cyberark/secretless-broker, and you will be able to just verify what exactly is capable of. So highly recommended. And I guess we are running out of time, so I want to leave some time for Q&A. So again, thank you so much. These are some of my handles. If you guys would like to get in touch with me, there's plenty of things that I didn't have time to talk about. It was short, 20 minutes, and we're actually a bit out of time now. But again, so feel free to ask me any questions now as part of the Q&A session.